像红卫兵啊。对啊，我也是没有。这里有版。哦，你们是拿电脑吗？有电脑。你们要不要画
？Okay, why don't we get started? Okay. I appreciate you all. You come here for the makeup class. I understand the time is bad. So if you have dinner here, just feel free to take your dinner. Make sure that keep the place clean, and that should be okay. Okay. I'll keep it. I'll keep finished before 9. So I hope you won't run too late. Okay. So this time I will continue on the network security part. So last time we basically talked about different types of attacks that you can launch in a network. So we start with the passive sniffing. So you can install a sniffer tool, for example, the Wireshark, to eavesdrop the traffic within in your nearby in your neighbors. Okay. For example, in the wireless medium, you can sniff the traffic within the wireless communication medium. So you can find out which one is sending the packets. Okay. And also, but the requirement is that this communication medium has to be a broadcast medium, meaning that even though the packet is not destined for yourself, you are still able to get this packet by enabling the promiscuous mode. Okay, so the idea of the promiscuous mode is even though the destination address is not for yourself, but you are still able to receive this packet. Okay. Now, in some network, for example, if the computers are connected by the switch, then basically it's not a broadcast medium. So if the destination is not for you, the packet won't be delivered to you. Okay. However, you are able to use the ARP spoofing technique to mess up the mappings between the IP address and the MAC address, so that even though the address is not really for you, you are still able to get the packets. Okay. So this is pretty much about how you can get access to the packets that are not for you. Now, I will talk more about different types of attacks that you can launch in a network level. Okay, so today I'm going to talk about the TCP exploits. Okay. By the way, assignment 2 will be posted next week, so please check out. And that, some parts will be related to some of the topics in it. Now, last time we talked about you can actually create your own packets. Okay. Now, the idea of the ARP spoofing is that you create fake ARP request or response so as to mess up the mappings between the IP and MAC addresses. Okay. Now, you can rely on some existing tools such as bsnif, which you can just download by calling the yum install in Fedora, okay, or in Ubuntu you can call the apt-get install. Now, in fact, you can use the socket programming techniques to craft your own packets. So the idea is very simple. You just need to set the correct options. Okay. So for example, all you need to do is to set the socket packet, and with the option if p all. So what that means is you tell the socket to try to create a packet starting from the Ethernet level. Okay, so this includes all the way down from the Ethernet header up to the application payload. Okay, so of course you need to fill in each field correctly. Okay, but the idea is that you can set the fields that you want. Okay, so the idea is if you set the socket like this by setting the correct option, then you are able to craft your own headers and payload from the link layer to the application layer. Okay. Now, in some situations, you may not need to generate fake Ethernet header. Okay, you may consider just starting from the IP level. Okay, so the idea is applied to IP address spoofing. Okay, the idea is that you try to create a packet with the fake source IP address. For example, let's say if I want to bump you a lot of traffic. Okay, when I send you a lot of traffic, that will be the source IP address and the destination IP address. Now, if on the receiver side, you may find out which one is the attacker by checking the source IP address. Now, however, you don't have to use your own IP address, okay? Because the whole idea is you just want to bump the receiver with a lot of packets. So one thing you may want to do is to create a fake source IP address. So this is what we call the IP address spoofing. For example, you may send the DNS queries with the spoofed source IP address. Okay. Now the DNS server will use the source IP address to return the reply. Now, if you want to attack a victim, so what you want to do is you set the source IP address with the IP address of the victim address. So later on, the DNS server will send the replies to the victim. Now, in that case, the victim will be bombarded with a lot of these DNS replies. However, there's no way for the victim to find out what is the attacker, because the attacker in here is actually the DNS server, which is supposed to be legitimate. So in that sense, you are able to, from the attacker's point of view, he'll be able to avoid being detected. Now, to do the IP address spoofing, all you need to do is to craft everything from the IP header to the application payload. So all you need to do is to set the socket raw and also IP protocol raw. In that case, you will have the control from all the way from the IP header all the way to the application payload. Okay. The whole idea here is that you can just use the simple socket programming to create your own packet. Now, I will use this packet spoofing example to illustrate how you can launch an attack called the TCP exploit. Okay. Now, last time when we talked about the passive sniffing or the active sniffing with ARV spoofing, so the idea is you want to access the content of a communication. Now, but the thing is, if people are talking using SSH, then even though you may get the content, this content is all encrypted. So if you don't know the key, there's no way for you to tell what the content is. Now, but you may still want to bring some damage to a connection. So in this case, you may want to just simply kill the connections to deny the service. Okay, so maybe, for example, you are doing a homework. Okay, you are connecting to the department machine to do your homework. Now, I'm your enemy. I don't want you to finish your homework on time. So what I want to do is I can launch this attack. Now, this attack will work even though you are using an SSH connection. So this is a very dangerous attack. So I will show you how you can do that. Okay. Now, the whole idea is to exploit the fundamental characteristics of TCP. So if you want to fix that, one thing, probably the most effective way is to change the TCP protocol. But that's not feasible because that also affects all the software that is built on TCP. So this attack is actually very dangerous. Okay. So the idea is to use the IP address spoofing to try to map the packets to its TCP connection. Now, this attack is to exploit the fundamental characteristics of TCP. So to understand this attack, we need to understand the fundamental characteristics of TCP. Okay. Now, probably you have learned this in the network course. Now we will try to look into the key information that you need to launch the attack. Okay. Now, for TCP connections, okay, usually there will be 4 tuples to identify connections. Okay. It's a process-to-process communications. Okay. You have a process on the source side, and you also have a process on the receiver side where the process will talk to another process. Okay, you can guarantee that these connections will be reliable, so that all the packets will be delivered and there will be no reordering. Okay, now each connection will be identified by this 4 tuple: the IP port, destination IP, and destination port. Okay, so one machine which has the same IP address could have multiple port numbers. Okay, so in this case, one machine could have multiple TCP connections. Okay, and also, for example, one IP and one port can accept many different types of source IP and source port. So the whole idea is, as long as these 4 tuples are unique, you can uniquely define a TCP connections. Okay, and TCP basically will try to look at the data as a stream of bytes. Okay, now because TCP wants to guarantee the reliable delivery, what it means is you want to make sure that no data is lost. Okay, so in here you need some sort of sequence number. Okay, to identify what is the beginning of the segment and what is the end of the segment. Okay, so you will use this sequence number to keep track of whether each byte is correctly delivered. Okay, and the acknowledgement basically is to tell the other side that actually your packet has been received and I will expect the next byte. Okay, so more formally, sequence number basically is to identify the first byte of the segment. And the acknowledgement number basically is the sequence number of the next byte expected from the other side. Let me give you an example of what that means. Okay. So this is the slide from the network course. Okay, so I will just repeat this in here. Now, host A and host B wants to talk to each other through TCP. Now, more precisely, it should be one process in host A talk to another process in host B. Okay, it's a process-to-process communication, not a host-to-host. Okay, so one process in host A talks to one process in host B. So to begin with, they need to have a three-way handshake. Okay, so they need to share the so they need to set up the connections. Okay. Now, after they set up the connections, so they will start to talk to each other. Okay. So host A may, let's say he wants to send hi. Okay. So in TCP, it will treat the segment as a byte stream. Okay. So there will be 3 bytes to send. Okay. H, I, and the exclamation mark. Okay. So so somehow the host A will send this to B maybe in one single segment or maybe in multiple segments. Okay. Of course, in one segment, the minimum size will be 1 byte. Okay. However, it depends on it will depend on a lot of conditions. For example, maybe it depends on the existing kernel buffer, or maybe depending on for example, the socket option that you send. But in any case, the segment size may vary. Okay, sometimes you're able to send 1 byte. Sometimes you may be able to send more bytes. Of course, it also depends on when this byte stream comes. Okay, so for example, let's say host A type in H, but later on wait for some seconds and type I and exclamation mark. So in this case, I may try to break these hi into 2 segments. So let's assume that we break this into 2 segments. So I first send H, and then I will send I exclamation mark. So in here, I will send sequence number 1, acknowledgement 1, and data H. Okay. Let's assume that initially I will set this value. Okay, like this. Okay. Now B will wants to send byte back to host A. So it will send the byte in here. Now this acknowledgement number basically means to acknowledge this sequence number 1. Okay, so the idea is that I already received 1. Okay, the sequence number 1, which is the beginning of the first byte, and also the size of the data is 1 byte. So if I send the acknowledgement number 2, basically it means that the next sequence number that you should send will be 2. Okay, so when host A receives this acknowledgement, basically I can safely tell that the previous segment is correctly delivered. Okay, So I will send it back to the host B. And remember that right now this enlargement number will be equal to 4. What that means is I'll expect the next sequence number to be 4. Now precisely, how do I set this value? Okay. So basically, the first rule is that the sequence number will follow exactly the enlargement number reported by the other side. Okay. So, for example, the enlargement number 1 in here means that when you send something to me, I'll expect to send you send me the enlargement number 1. Okay. So, for example, if you lose a packet in the middle, so you may not enlarge you may want to repeat this number. So, for example, if this packet is lost, then I will still set the enlargement number to be 1, so that to make sure that, hey, send me the packet, send me the byte starting with sequence number 1. Okay. So this enlargement number, this sequence number must follow the enlargement number reported by the other side. Okay. So you can see this rule in here. Okay. This sequence number will correspond to the enlargement reported by the other side. Okay. And another rule is that the enlargement number will be set by the sequence number of the received segment plus the data length in bytes. Okay. So why do I set 4 in here? It's because the sequence number is equal to 1 and the length here is 3. So I receive this byte stream, okay, and I would expect that the next sequence number to begin with will be 1 plus 3. So that's why I will set 4 in here, okay. Now how do I get this 4 in here? Is because the sequence number is 2 and the length of this data stream is 2, so I will get the 4 in here, okay. Now of course, this example only shows you the ideal case. There's no packet loss and there's no reordering. Now, if there's this kind of unexpected issue, TCP will still work. So I won't go into the details in here. So you may look up the network textbook. But the whole idea is that you use the sequence number and the enlargement number to define how you actually send the packet or receive the packet. Okay. Now, well, to begin with, we need to define what sequence numbers that I should use. Okay, so in here, basically, we will use the TCP three-way handshake. So the idea is you use this three-way handshake to set up a connection. Okay, and also it will define what sequence number to begin with. Now, let's say host A wants to talk to host B. Okay, so in this case, A will send a sync packet and pick a sequence number. Let's say I randomly choose 1. Let's say it's 100. Okay, so host B will receive this sequence number, and it will return the sync ACK. Okay, sync ACK basically consists of 2 information. One is I acknowledge the receipt of this sync packet, and also I want to set up another sync packet. So sync ACK basically contains these 2 pieces of information. Now, the sequence number will be generated by B. Okay, so B will say, hey, let's start with 300. Okay, and 101 basically is defined by the sequence number of this sync packet plus 1. Okay, so this is the three-way handshake design. So the enlargement number will be defined by the sequence number plus 1. Now, of course, in sync packet there's no payload, but this is a very special case. Okay, so if I receive the sync, I will just add 1 in here. Similarly, host A will just treat this as 1 byte, okay, and we just set this to 1, okay, 101, okay. The sequence number is based on the enlargement reported by the other side, okay, and also the enlargement number will be 301, which is 300 plus 1, okay. This is the way of how you agree on the sequence number to begin with on both sides, okay. So these are the three-way handshake. You send the sync, okay, the other side send you back the sync ACK, and you send back the ACK to the other side, okay. And then after that, both of the processes will go to the established state and they can exchange the data. And they will follow the two rules that I just mentioned to exchange the packets and set the sequence and enlargement numbers. Okay. Now, let's say host A wants to finish the connections. So what it does is it will go through four exchanges of packets. Sometimes we call it the four-way handshake. Okay. So the idea is I will send a fin to host B. Okay. And B will enlarge the fin. Okay. And B will send a fin again, and finally will be the enlargement. Now you might be wondering why I don't just put fin and egg together. The reason is that it is possible that when host B send back the enlargement, host B may still have some outgoing packets. Okay, it may want to still flush the packets inside its buffer. Okay, so it cannot finish immediately. But once it send out all the packets, it will send the fin to the other side, and both sides will agree on closing the connections. Okay, but in any case, the idea is I will send the fin, and egg. Okay, so both sides will agree on closing the connections. Now, if you look at this protocol, okay, basically the whole idea is to look at the sequence number and the enlargement numbers. Now, everyone can set the enlargement numbers and the sequence numbers. Okay, if you're able to spoof a packet, you can generate your own sequence number and enlargement numbers. Now, of course, if host B sends some sequence numbers, let's say it's 700 instead of 600, which violates the rule that I mentioned, okay, it doesn't follow the enlargement number on the other side, then the process will just drop the packet. Now, it is possible for the attacker to try to generate packets that correctly match the sequence number, but for different purposes. So that's the whole idea of the TCP exploit. Okay. So the idea is, as long as the for tuple is correct, and the sequence numbers is correct, with both of these informations correct, then the TCP packet will be accepted. So the idea of the TCP exploit is that, okay, I will generate a fake fin packet or a reset packet with the correct for tuple and sequence number to kill the connections. The idea here is that TCP doesn't look at the payload, okay? It only looks at the sequence number and the for tuples to decide whether I should accept the TCP packets or not. Now, host A and host B may be communicating with each other. They are exchanging the packets. But somehow you may be able to generate a fin packet in the middle as long as the tuples and the sequence numbers are correct. These TCP packets will be processed, and then the connections will be closed. That's the idea of the TCP exploit. And the reason is that TCP doesn't check the payload, and also really doesn't check the origin of the source. Okay, there's no authentication being involved. They just assume that if the for tuple is correct, the source IP will be the corresponding source. But it turns out that it's not really the case in here, because everyone can craft its own packet. So this is the whole idea. Now, this is a very simple illustration to show you how it works. Okay. Now, let's say host A and host B will talk to each other through the wireless, let's say. Okay. So somehow, if I put a sliver in this medium, in this wireless medium, I will be able to see all the packets being exchanged between A and B. Now, somehow, I just see the packet sent by B, the last packet being sent by B, okay, in here. So what I'm going to do is I will generate a bogus packet to try to set the fin, okay, back to the host B, okay. So the idea is I map the correct A, B, A, and B, okay. So these four tuples are correct, and also the sequence number follows the enlargement number on the other side, then I will expect that everything will work. Okay, so in here, but this time you send a thin flag, okay, in here. So if that's the case, you send it to B, then the B will just process this packet, and because it sent a thin packet in here, then it will start the four-way handshake process. So the host B will think that A is actually sending the thin packet. It wants to close the connections, okay? And somehow B will start the four-way handshake process. And A will somehow, hey, why do you send this packet? And eventually, it will close the connections. We'll see the detail. Now, the whole idea in here is the attacker will generate this bogus packet. And once this bogus packet is generated, the connections will be killed. Let's see why, okay? So let's say I want to generate a thin packet to host B. Now, what does host B do? Okay. Now, host B will process this thin packet and start the four-way handshake. Okay. So, host B will acknowledge this thin packet. Okay. He thinks that host A is closing, so it will just close. Okay. So, the sequence number follow the enlargement number. The enlargement number will be this one, 305 plus 1. Okay, this is the, just treat the thin packet as 1 byte, okay. And then we will also send the thin package to A. Now, from here, this is the first time that A receives this thin packet. So from A's perspective, it will think that, hey, B initiates the closing. Okay. Now B thinks that A initiates the closing, but it turns out that it's the attacker initiates this. Okay. Now from A's perspective, this is the first time it receives this thin packet. So and the sequence number and basically the sequence number basically just follow the add number, because this is the last time the add number is 600, so it follows. So this thin actually is correct. Okay, so it thinks that B is closing. So A in here will send the thin back to host B. Okay, it should send an add back, but it doesn't matter. Okay, now things get funny. Okay, now when A send this thin packet, this time the sequence number is 305. Okay, 305, how to generate this is based on the this enlargement number. The next one should be 305. Okay, and the enlargement number this time will be 306. Now, however, B, actually you send one more packet to B. B, it would expect that it should be 306. But now you send me 305. So B, from that sense, it will ignore. Okay? It should expect the 305. But A will set it to 305 is because the add packet for the last time should be 305. Okay? And then just resend. It will be ignored again, and that will be just reset. Okay. Now you may be wondering why is 305 not 306. Okay. It is still 305 is because host A basically will send 301 to 345. Okay, so the next one should be counting from 305. Now things get messed up in here. Okay, so it doesn't really follow the rule anymore. So in here, A, if you look at what A has already sent, previously we sent 301 to 345. Okay, the next one that it should send will be starting at 305. Okay. it sends back the fin in here. Okay, the sequence number is correct. Okay, so it will accept this fin packet, and A in here will just send fin starting with 305 instead of 306. Okay, but there's another packet sent in the middle to host B saying that, hey, I should expect 306. So this one is ignored, and this fin will be ignored. And finally, if you generate a lot of these kind of generate a lot of wrong packets, it will just close it. Okay. The thing is, B already initiates the closing. Okay. You should no longer expect more packets from the other side. Okay. So if the sequence number is not correct, it will just ignore. But eventually, after some time out, okay, if it knows that there's no need to wait for more packets, it will just kill the connection because the four-way handshake is already initiated in here. Okay, so the idea is once you generate this packet, this process will be closed. Okay.
I have a question.
Yeah.
The packet on the black packet under the red packet. From host B to host A, the ACK number is actually wrong. Because host A thinks that the next sequence number should be 305, but the ACK number from host B to host A is 306. So why host A will accept it instead of drop it?
Now this one is 306 in here. This one is correct, okay, because the fin here is 305, okay.
But this is tag in the eye of host A. The next sequence number should be 305, right?
Yes, yes, yes.
But host A receive a package. The package ACK is 306, so host A will think this package is wrong. So it's reasonable for host A to drop the packet instead of receive it.
Well, by the design of TCP, it doesn't check this enlargement number. So even though this enlargement number, because as long as the sequence number is correct, because the sequence number here is that I expect the next sequence number to be 600. This is the information that I need to get.
So host A will
still
accept this packet anyway, even
accept
if
this
the
packet
ACK
anyway.
is wrong.
Right. Even the ACK is wrong. But in here, so right now this sequence number is 0305. I mean, intuitively this should based on this 306, but this doesn't follow the 306 anymore because this one is messed up. So somehow 305, how the 305 is set is based on the sequence number, okay, and the length of the data. Okay, so in this case it will be the 305 instead of 306. Okay. Now even though it's 306, it will still be accepted in here. Now this is the scenario of host when you send a bogus packet to A. Now B actually, if you send a packet to host A, that will be dissimilar. Okay, all you need to do is to check the correct sequence number and the ACK number. Okay, so again, I look at this enlargement number. Okay, I send a fin immediately. Now this fin basically is based on the enlargement from host A, which will be 600 in here. Okay. So I send and I will send this fin to A. Okay. A will enlarge this fin. Okay. And we send another fin again. Okay. So that will be 305. Now host A will pick this fin packet and generate another one, which will be 600. Now this 600 will be based on this sequence number. Okay, enlargement doesn't have any length. Okay, so it will just treat it as 0 bytes. Okay, and enlargement will just enlarge this fin. Now this one, but the thing is, I will expect it to be 601 because I already received the thing. I acknowledge you to send the 601, but you send me 600, so I will just ignore. Okay. If it is not, then you will just eventually you will just send the reset to immediately close the connections. Okay. Maybe is there any questions in here? Now the acknowledgement itself doesn't have the length, okay? So you can just treat it as 0 byte, okay? When you send an acknowledgement, the next packet sent by host B will have the same sequence number as the acknowledgement, okay? And host A, basically the sequence number will be based on the last one that it sends, okay? So 300, 1, 2, 3, 4, 5, so the next one should start with 305, okay? Yep.
Since host A has sent B a packet direct with the acknowledgement of the 601, why host B will send a free package with sequence number of 600? How does B generate this package 600?
Okay. I should say in this way. Okay. So now, in the normal situations, okay. Now, how do you set this sequence number and acknowledgement number? Now, first, now this is the normal case. Okay, if there's no new bogus packet, so we will expect that this sequence number will follow exactly the acknowledgement number. But in fact, actually, inside the implementation, in implementation, you actually treat each byte as a sequence number. So this H will have a sequence number H, okay? H will have 1, okay? This one I will be the 2. This one will be the 3, okay? So from A's perspective, it will just look at how many packets is sent and will generate the sequence number accordingly, okay? So similarly in here, now if you look at why the thing is 600, it's because if you look at the last time that is sent, okay, last time the packet that is sent, it will be the 600 for an ACK. Now ACK in here doesn't have any length. It's a zero payload. Okay, so if you just next packet will be 600 plus 1, 600 plus 0. The next sequence number will still be 600. Okay, now this sequence number should be based on the last packet that you sent. Okay, it is not based on the acknowledgement that you receive. Okay, now there's a reason for that, because it is possible that sometimes there's some let me think. Now, there's some situation you may want to, even though you receive some future acknowledgement number, but you may still want to send the same sequence number in here. For example, you receive the acknowledgement number 600. Now you prepare to send the sequence number 600. Okay, you already put in the buffer, but in the meantime, the network is so fast that you somehow get this acknowledgement number. The packets that you send out is also being acknowledged. So by the time you send out the packets over the network, you may already, so this future acknowledgement number also arrives. So in this case, this scenario actually is possible. Okay. Now, of course, from the receiver side in the normal situation, if I receive something from the old sequence number, I will just ignore it. Okay. And actually, this is the case in here. But I'd just like to point out that why this sequence number should be 600 is really because based on the sender side. Last time when you send the 600 in here, there's no payload in here, so it's still 600. Okay, maybe I'll show you a demo in here to give you a sense what that is. Okay. Now this is there's a free machine in here. Okay. So A, B, and C. Okay, so this is A, B, and C. Okay. Now they are all connected over a hub. Okay. Now what that means is when B wants to send something to C, A, by enabling the promiscuous mode, it will also receive the packet. Okay. Now let's say B talks to C. Okay. So let's say I want to set up a SSH connections to C. Okay. So right now B is on C. Okay, so I set up a connection to C. Okay. Now on the course website, I put a TCP exploit program in here. Okay, so you can actually download and run it. Now, but the thing is, you need to modify something first. Okay. Now this hub actually is in ETH1. Now this is exactly the same as your it actually is your assignment VMs. Okay, so it has the same setting as your assignment VMs. Okay, so ETH1 basically is the hub interface. Okay, so so A will be able to receive listen to, by listening to ETH1, you will be able to sniff the B and C. Okay. Now, when you download the program, actually it will look something like this. Okay. Now, you need to define the interface correctly. I think by default it's something like VMnet1, but just change it to ETH1. Okay. Now, you don't need to change the other things. But if you look at this program, what it does is it tries to craft a spoofed packet. Okay. So the whole idea is to send the packet accordingly. Okay, so the idea is that you try to sniff the packet with the same source, with the same for tuple. Okay, whenever they receive the packet, it will try to generate the packet. Okay, by setting this ACK and this ACK with the data link. So this one actually corresponds to it should be this one. It should be this one. Okay, so you treat this as the source and you treat this as the destination. Okay, so when you receive this packet, you just send it back to this one. So you look at the so the sequence number will be same as the acknowledgement in here, and the acknowledgement number will be this one plus the data length. But this one is the ACK, so I will just set to 600 in here. Okay. Now, first thing you need to do is to identify the connections. Now, what you can do is you can just leave the communication between these two hosts, okay? Or to just make things simple, I just do the next step on the other side so that you can quickly identify the port number, okay? So you can see that these two hosts are talk to each other. O2 will be the VMB and O3 will be the VMC. Okay. Now this is SSH, so the server side port will be 22, and the client side port in here will be 49802. Okay. Now of course you won't type that on the victim side to find out what the port is. You can actually do the sniffing to find out the port numbers. But just to keep things simple, I will just do it in this way. Now, what I will do is I identify these port numbers and run the program. Okay, so you would take the, I already compiled the program, okay. So you type in the number, okay. It doesn't really matter whether this is the beginning or the end, okay. You just provide the correct 4 tuple, okay. So that would be okay, okay. Now, you need to have the root because this program will specify the promiscuous mode, okay. So you just do the sudo and we just run, okay. Now, you just type in something in here. Then eventually, it will listen to packets. Now you can see that the connection is closed. Now originally it's C, but somehow I suddenly receive a closed connections. And if you look at in here, the thing is, in this sequence, okay, I sniff a packet and I insert a bogus packet, and it will exactly look something like this, okay. So in this case, this connection will be closed. Now, how do you see this is closed? Now, originally I'm on BMC. Right now, my connection is closed, so I'm kicked out, and I'm now on BMB. Okay, so this is the TCP exploit attack. And 2 things to notice in here. One is, I'm using the SSH connections, but it doesn't matter because SSH only protects the application layer, okay? Only the application layer payload will be encrypted. But the TCP, IP are not encrypted because they are just sent in plain. So I'm able to find out the TCP header information. That's one thing. And the second thing is, in here, I need to assume that I'm able to do the passive sniffing so that I can find out the packets. But if you notice in here, that's not very difficult to launch. Okay, for example, if using wireless medium, actually this attack is feasible. Okay, and right now we still have no way, really good way on how to defend against this attack. Now, of course, I made some suggestions in here, but you can see that whether it works or not. Okay, now sometimes if I were an attacker, I want to maximize the attack. For example, if you notice the example, I may try twice, okay, in order to successfully launch the attack, okay. But the reason is that I may somehow send a bogus packet later. For example, if you go back to this example, let's say I listen to this ACK packet, so I send a FIN to B. But maybe by the time you listen to the ACK, maybe already A generate another packet already. So in this case, FIN will be ignored. Okay, so somehow you may generate the packet late. Okay, so in this case, you may not be able to launch the attack successfully. So somehow you may want to try several times in order to achieve. Or you may just try to fire multiple FIN packets with the increasing sequence number so as to make sure that one of these FIN packets will be processed. The reason is that you miss the chances because the other side also send another packet to raise the sequence number. So in this case, you may just increase the sequence number to make sure that your FIN will be processed. And also, instead of sending the packets to one side, you send the packets to the other side as well. Okay, so that one of them will start processing this FIN packet and eventually will close the connections. Okay, so this is the way of how you can maximize the chance of successfully launch the attack. Now, how dangerous it is the thing is worse even though you encrypt the traffic in the application layer. So one thing you need to do, maybe you somehow protect your traffic in a lower layer. For example, you may want to use VPN, okay? The idea is that VPN will protect starting from the IP layer. So the TCP headers will be treated as the payload. So in this case, you won't be able to find out the TCP header information. Now, if you look at the program in here, okay, so it will take several information as input. sorry. So in here, the TCP exploit program will receive several information. The idea is that you wait for the packets with the source IP, source port, destination IP, and destination port. You wait for these packets with the same 4-tuple information, and then you launch the attack. Now, in the case of VPN, you won't be able to find out this information because the TCP header is also being encrypted. So in this case, the TCP exploit will be protected. Now, but the thing is, if you use the VPN every time, your performance will be bad. And also, it doesn't really make sense to launch the VPN in a local network because usually inside the local network is a private network supposed to be everyone is trusted. So the reason of using VPN is we want to set up a private network on top of a public network. But the attack that I'm talking about in here is really for the local network. Okay, so if you use VPN or you use IPsec, it works, but you may have some performance degradation. Okay, you will see the performance drop. Okay, so this is a very dangerous attack. Now you can see that actually you can launch the attack within our department. So just make sure you don't do that. Okay. Okay. Any questions? Okay, so let's finish the 2 more attacks before we give a short break. Okay. Another one is called the session hijacking. Okay, now basically the idea is very similar to what we discussed last time. Okay, again, it's based on the ARP spoofing. Now, the idea last time when we talked about ARP spoofing is really about sniffing the packet. Okay, so the idea is even though you are in a switch, okay, you are still able to find out what the packet is. Right now in here, I want to get control of the session. Okay, not only find out what the packet is inside, but I may want to just take control of the whole connections. Okay, so the idea is that Alice will want to has an existing session with Bob. Okay, she already has a session with Bob. Okay, now Eve just leaves the traffic between Alice and Bob. Okay, and then somehow inject the traffic nicely such that Alice and Bob, they think that they are talking to each other, but in fact it's the traffic from Eve. It's just like the man in the middle attack. Okay, so the idea is the same. But the thing is, the information is not really from the other side, but it's from Eve. Now, last time when we talked about the eavesdropping with ARP spoofing, the attack is the traffic is still from the correct party. Okay, it's still from Bob or Alice. But this time it's not really from Alice and Bob. It's really from an attacker. So this attacker may generate some fake information to disrupt. For example, you just say some bad words. Okay, so Alice will think that Bob says bad words, but in fact Eve is the one who generates these bad words. So this is what we call the session hijacking. And the idea is very similar to ARP spoofing, but this time we will introduce you a tool called the hunt. Okay. Now this is the scenario. Okay. Again, the whole idea is based on ARP spoofing. Okay. Now so the idea is that Eve will just send the spoof ARP replies to Alice and Bob. Okay. And Alice will, for example, Alice talks to Bob using the IP address Alice has the IP address ABCD, and Bob has the IP address WXYZ. Okay. Now Eve will just send a spoof ARP request with the IP address of Bob with her own with another MAC address, okay, and also it will send the ARP spoof request with A, B, C, D, and also this fake MAC address. Now, notice that the MAC address is not Eve's MAC address. Okay, I will show you a reason why. Okay, but in any case, the whole idea is you send the MAC address. Sorry, you send the spoof ARP to A and B with a different MAC address. Okay, supposedly Alice received a correct ARP with w.xyz, and MAC should be B, all B's. Okay, but this time it received something different. Okay, and same thing for ARP and to Bob. Okay. Now the thing is, in this case, East will receive all the traffic. Now this is kind of confusing. You may be wondering, hey, why the MAC address are different from Eve's MAC address? Okay. Now it turns out that it will work. Okay, with the following reason. Okay. Now, actually, if you still remember, switch has a learning function. Okay, it will try to learn the new MAC address and will store the mapping for the port and as well as the MAC address. Now, they will just treat this MAC address as some other new Ethernet card. Okay, maybe there's some new machine joining the network. Okay, so in this case, if I receive the MAC address, new MAC address from a certain port, the switch will learn this port and put this port and the fake MAC address inside its own switch table. Okay, so the idea is, if the switch in here received this mapping, so what it means is that if I got the MAC address with all these, then I should send the frames to this port, which will also go to Eve's. Okay, Eve just make sure that it will enable the promiscuous mode, then it will receive anything. Okay, so in this case, even though for the fake MAC address, but it still works, it's because the switch has the learning function. Okay, and the thing is, when the switch receives the frame, okay, it will try to forward the frame to that port. Now, what makes things more interesting is you actually can avoid being detected by using a fake MAC address. Okay, if somehow somebody is leaving the somehow is monitoring the packets, but you see something MAC address, there's no way to find out which attacker generates this MAC address. Okay, so actually in this scenario, you can actually use the fake MAC address. Now, but this work for modern switches. I think if you buy most of the switches, you are able to use that. But I'm not sure if you can do this in our VMs, because the interface actually is not really a switch. Okay, it mimics the switch function, but it may not really. It's not really a switch. So I doubt if this work in a VM setting, but you may double check. Okay. Now, but the thing is, in a commodity switch, actually this would work. Okay. So I'm not going to detail in here, but in here I introduced you to call the hunt. Basically, you can use the hunt to launch the ARP spoofing and also hijack the tenant session. Okay. And I put a PCAP file on the course website, so you just make sure that the MAC address is the same. I use the same MAC address to launch the attack to make sure that it really goes into this host. But in fact, in the real switch network, it can be a fake MAC address. Okay. Now, more generally, you can generalize this attack to a larger network. Now, the example that I showed you is really a single LAN. Okay. Now, in fact, it doesn't have to be a LAN, or it could be multiple LANs. Okay. So the thing is, Alice and Bob may be located in two different subnetworks. For example, Alice is in IE and Bob is in CSE. Okay. And there's an Eve sitting somewhere in the engineering building. And what they compromise in here is not Alice by herself, but you actually compromise the gateway router. Okay, so as long as you find out the gateway router, you just send the fake ARP spoofing, and this will work. Okay, so the idea is, even though the router is basically just nothing more than a machine. Okay, just like a machine. Okay. You generate the fake ARP, the router will just treat this ARP like what the physical machine does, what a desktop does. So in this case, it doesn't really matter whether it's a router or it's just a desktop. Okay. Now, session hijacking is very dangerous. The thing is, it's just like the man-in-the-middle attack. Okay. Once it's successful, you have no way to identify the origin of the other side. Okay, so you may want to make sure that you're really talking to the right person. Okay, so in this case, you want to make sure that when you receive the certificate, you want to make sure that this certificate really belongs to the right person. Okay, once you verify the certificate, you make sure that only the authorized person can sign this message, because remember, the certificate has the public key. Now this public key will verify only one single signature, only verify the signatures generated by one single private key. For other people, they don't have the private key, there's no way for them to generate the correct signature, there's no way to launch the man-in-the-middle attack. Okay, so you may want to make sure that the certificate is correct. Okay, and also this technique is really similar to the sniffing or spoofing. Okay, so make sure that this ARP spoofing is doesn't work. Okay, so you may use this technique to do this. Okay, now another thing that I like to point out in here is you may want to use some intrusion detection techniques. Okay, now. The reason is that sometimes it may be difficult to take action immediately. Okay, for example, one technique that you want to use to defend against ARP spoofing is to hard code the mappings. Okay, you hard code the IP and the MAC address mapping so that nobody else can fake the mappings. But actually, it will be very difficult because you somehow need to re-engineer the switch to hard-code the mappings. One suggestion is that one solution that you may use is to use some sort of intrusion detection. First, collect all the evidence. Okay, collect all the evidence first, and then later on take the actions. Okay, if you find out some hosts generate many gracious ARPs, then it may be abnormal. So in this case, you want to pinpoint the attacker. Now, this solution will delay the protection. Okay, you cannot defend, you cannot actively protect against the attack. This is something like the you do it after the after the incident. Okay, but the thing is, you minimize the interruptions to the network because you don't want to modify the switch to hardcode everything. Okay, by doing this, it's simple to deploy with the drawback of delaying the action to find out the attacker. We'll talk about that 2 weeks later when we come to the intrusion detection. Okay. Any questions? Now finally, I will talk about a tool which you can launch the attack. Now this is called the netcat. Netcat by itself is not really an attack tool. It's really a good tool for people to do the monitoring. Okay, and also it's easier for people to remotely control a machine. But somehow this tool could be used maliciously to control a machine. I would talk about that to just really for completeness. I mean, it's not really as dangerous as these type of attacks, because if you really want to launch the netcat, you need to make sure that this netcat is installed on the victim's machine. But somehow, how to put this tool in your victim's machine is another story. Okay, but let's assume that we can do that, and let's see how we can use this tool to control a machine. Now, because the whole lecture in here is about how to gain access to a network. Now, somehow netcat is one tool that you can gain access, but I just like to point out that, like many other tools, when they first designed, they are not really for the bad purpose. Okay, so keep this in mind. Now, again, this is a general tool to try to remotely control a machine. Okay, it's just like a Swiss Army knife. It's like so just like when you go to picnic, you want to bring in a knife that can do everything. Okay, so this is the Swiss Army knife. So basically, you can use this to open a can. Okay, you can use this to cut something, or you can do it with anything. Okay, so it's like it's a very universal tool. Okay, now originally people put in netcat is because I want to create a backdoor in some machine, so that later on I can access the machine to find out what it is. For example, I will show you exactly what you can do with netcat, so that you can think of how it's being used for good purpose and a bad purpose. Okay, but in any case, I will show it from an attacker's perspective. Okay, now netcat, cat actually stands for in Unix you have a command called a cat. Okay, you can show the cat a file, then you can show the content of the file. Okay, netcat basically is the network version of cat. Okay, when you netcat a file name, it will display all the files. Okay, so this is what it means. So it's really the network version of the cat command. Now, well, the idea is actually just nothing more than the simple socket programming. Okay, so actually you can just write your own netcat using socket programming. But of course, netcat provides all the options that you need, so you don't need to re-implement it. But the idea here is that you can run the netcat on one side and the netcat on the other side. So there's a client mode and there's a listen mode. So the client side can control something on the server side, okay, and you can send data or with data using the TCP and UDP. So you just like create a backdoor on the other side in the listen mode. This is the backdoor, and the client side will just go through the backdoor and control this machine. Okay. So the idea is like you have the destination machine. If you want to receive a file, okay, so let's say I put it in the listen mode. I'm listening to the port 1, 2, 3, 4. Okay, for every content that I will receive, I will just dump it to a file. Okay, on the service on the client side, it will just connect to the machine and the port, and will just cat the file. So what it means is you try to catch the file. Okay, when you type cat file, it will display the file. But this time you're not displaying on your own screen, but this time you display it on the other machine, and the other machine will redirect this to a file. Okay, so the idea is you're pushing a file across the network. Okay, it's just like the cat command, but this time you push the content not on the screen but on the other machine. Okay. Now similarly, you can also pull a file. Okay, so for example, on the other side, you put the listen mode. So this is the client side will put the listen mode. Okay, and the destination will run this command and will dump this to the file, but actually it will send the file to the listen mode, and it will also receive the data. So this is just the other way around. Okay. You can also use the netcat to do the port scanning. So what it means is you can check the port. You can provide different options and set the ports, and you can use this command basically means that if the port is open, then you can write the data to this port. Otherwise, you cannot. Okay. But netcat is just one tool that you can do the port scanning. I'll show you another tool in a moment called an nmap, which provides more options. But I just want to show you in here that you can do it with netcat. Now, what makes things more dangerous is like this. Okay. Now, netcat allows you to push a file or receive a file. Okay. Now, that's nothing interesting. Okay. If you push me a file, if I'm the victim, I will just delete the file. Okay. There's no damage, right? But one thing is, you are not only just push a file, but actually you can run the command on the victim side. Okay. You are not pushing just a file, but you can also push a command. So let's say you send an email to the victims and ask the victims to install the netcat. Now this is a very strong assumption, but let's say we can do that. And somehow the victim will run this command. Now what that means is, on the victim side, it will enable the listen mode. It will open a backdoor on 1234 and generate this listen mode, and also it will execute some command called the bin and shell. Okay. Now on the attacker's machine, it will run nc victim machine and 1234. Okay. So what that means is, when you connect to this victim's machine, okay, it will go inside the shell. Okay. Because if you remember what that is you push something to the victim's machine. Now, because the victim's machine opens the shell, basically you push something to the shell as well. Okay. When you push something, the victim's machine will run the shell. This basically will run the shell with the information that you push. If the information that you push is a command, basically what that means is you're running a command on the victim's machine. You push some data to the victim's machine, and the victim machine will use this command to execute the data that you push. By doing this, basically it means that you run the command inside the shell. Now, what's the implication? Now, of course, if you're able to make the victim's machine do that, the attacker's machine can generate any command it wants. For example, it can generate the remove *** to remove everything on the victim side. Okay, so this is the damage that it can bring. Okay, so netcat allows you to do that. Okay, now of course the first assumption in here is you need to make sure that the other side will actually install the netcat. Okay. So one thing is when you use netcat, you may actually, it may not work if there's firewall. Okay, so the thing is you create a port on the victim side. Okay, it listens to a port, let's say 1234. But this port, usually 1234, is not a well-known port, so the firewall may block any incoming connections to the port 1234. So in this case, it may not work if there's a firewall. Now, to get around this, one thing the attackers can do is instead of creating the listen port on the victim side, the Trudy can create a listen port on her own machine and gets the victim to push its command to the Truder's machine. Okay, so basically the idea is called the reverse shell. Okay, so how to do that? On the attacker's machine, it will run the listen mode, and the victim machine will push the shell command to the attackers. Now what attackers got is the shell. Okay, so by doing this, the attacker will receive the shell, and in this case, it will work on the shell, the victim shell. Okay, again, it will call the any command, but this command this time will run on the victim's machine. Now, what's the difference between this one and the previous one? Okay, now this is the passive backdoor, meaning that the victim will wait for the command from the attacker. But the problem is this port may be blocked. It may block any incoming connections. Okay, however, firewall doesn't block any outgoing connections. It's just like, think about in a CSE department, okay? You can usually connect to outside, but it's difficult from the outside to connect back to inside, okay? For example, you can go through the browser to visit any site, okay? But it's very difficult from the outside to visit any site within the CSE department, okay? Because there's firewall. So the idea here is that if you, instead of receiving the incoming connections, you make the victims to initiate the outgoing connections, it will be very difficult for the firewall to block these connections, and this will make the attack still worse. Okay. And Netcat allows you to set up multiple hops. Okay. So the attacker may just go through multiple relay. Okay. The relay may generate both the listener and the client, and relay A may direct to relay B and go to the victim. So the thing is, you make the detection even more difficult, because this time you have to trace through multiple relays, and in order to find out, make the traceback more difficult. Okay. So somehow this Netcat is somewhat. It's a good tool, okay, but the thing is, people may use it for bad purposes, okay, and you somehow want to make sure that this Netcat will not run without your own, you need to make sure that you know that Netcat is running, otherwise that would be bad, okay. So, for example, you try to prevent any type of file transfer on Netcat, okay, or you try to block any arbitrary connections, okay. Try to set up a firewall to allow only the legitimate ports, okay. Or you may try to apply the patches to avoid unexpected executions of Netcat, or use some intrusion detection techniques, okay. Any questions in here? Maybe let's take a short break first, okay. After coming back from the break, I will show you a demo how Netcat works. Maybe we'll come back in 5 minutes, okay?其實個意思係其實個。
咁佢打咩嘅 output 就會同佢到跟住嘅。
其實咩？
没看到，打面去的哇，我没看到。哇，那我
发一些文件，对，其实没有， 当然就是用这个方法
每一个那种虚的电脑，你连接就可以提
然后由于这种情况下，发一些这边也是一样，也是从那个发东西发到去这个，反正效果是一样的，但是应该是不一样的说，发东西的时候，这之前没有讲，就是做可能是。谁先就是谁是，然后他是就是镜头或者上 connection 就说这个这无所谓的，但是实践一个是这样，这就是 meeting 这个事件，然后那个是相当于是这个是说这样在这个方面做一个。也没有。都是把它认识的比较完整。
Okay, why don't we continue? Okay, I just want to clarify a little bit about the use of netcat. Netcat basically is to push something over the network. Sorry, you send something over the network. Okay, either you use the push approach or you use the pull approach. But the thing is, you always send from one side to the other side. So you always want to send the data from the left side and to the right side. But you can use the push mode or you can use the pull mode. But the purpose is the same. You want to send the information from the left to the right. Now, the push mode, which is you set the listen mode on the other side, that's intuitive, okay? Because it's just like you treat this as a server, okay? And then you have some data, you want to input a file, you cat it, and you will display to the other side, okay? Basically, you just send over the TCP port, and you will listen to the on the other side. Now, pull mode basically is the other way around, but you still want to send something from left to right. So the idea is you ask the other side to first create a connection back to the listen mode. Okay. So right now, this time the server port is not fixed anymore. It's not this port anymore. The server port will be based on the client port created on here. So when you make a connections, you can get the client port, okay, you can get the port on the client mode, so you just treat it as a server, but this time you use the source port created on this side. So when you want to send something, you will send to the same port created on this connect mode. So again, you still send from the left to the right, but this is the pool concept in the sense that right now the client will pull the data from the left side, but the direction is always from left to right in this example. Okay. Now let me show you a demo on how you can use the netcat. Okay. Now you download the netcat from the website I show you, netcat.saltforge.net. Okay. I apologize. I only have one machine. I only install netcat on one machine, so I just show you in one single machine. But I put myself in two different directories. This one is on host 1. This one is on host 2. Okay. So if I want to make a connections to here, I'm on host 1 directory, but in fact I will move to host 2 directory. So if you're located in different directory, you can treat that you are in different hosts. Okay, think in this way. Okay, but they are in the same machine. Okay. Now both sides need to install netcat first. Okay, so I copy the binary to both of these folders. Okay, so if you look at these folders, you have netcat in here, and in here you also have netcat in host 1. So treat this one as host 1 and this one as host 2. Now remember that you actually can create a backdoor and execute the command. Okay, so this is what we call the passive backdoor. You treat this as the push mode. Okay, so the idea is the victim side will run the command. Okay, and the attacker, when you push any information, this information will be executed by this command. Okay, so for example, if you send the command rm, then the shell will execute this command based on your input of the data, which is rm. In that sense, the shell will also execute your command. Okay, or you can think of, you provide an argument to the command put in the victim mode. Okay, victim. Okay, so let's run this command to see what that is. Now, I want to send from the left to right, okay? So this one is the victim, okay? Host 2 is the victim. So what I'm doing is I type in this command. So right now, this host will be in the listen mode. Now, I will connect to this netcat, okay? I'll connect this netcat to here. Okay. And now you're on host 2. How do I know I'm on host 2? Just check where am I. Okay, I just type in pwd. Okay, so in here, I'm actually on host 2. Okay. What it does is basically you are executing the command on host 2. For example, you can create new file in here. Now, if you just quit these two programs, I create a.txt on this side, but if you check in here, there's a new file, a.txt, on the other side. Okay. So basically what it means is that you have the control of the other host. Now, of course, right now it's on the same machine, but you just imagine that you can generalize this to other machines. Okay. Now, this is the passive backdoor. Now, you may also ask the other side, to initiate connections so that you can push the thing, the pull mode. Okay, so what it means? Okay, so this is the attacker. What you do is you create a listen port. Okay, somehow you ask host 2 to make the connections back to host 1. Okay. But you also provide a command. Okay. Now what that is actually, what it does is it will make the connections to the host A, and the host A will send the data back to the host 2. So you still send this data from here to here. So right now, if you go back to the attacker, now once I know that the victim make a connections to me, so I can send command to the victim. So for example, I type in pwd, that will be on host 2. I create another file, p.txt. If you kill the program, you can see that that will be b.txt on the other side. Okay, you still send the command from the left to the right, attacker to the victim, but you can do it in 2 ways. One is you create a listen port on the victim side, okay, but that will be easily blocked by the firewall. Or the other way is you set up a port on the attacker side and ask the victim to initiate connection. That's what we call the reverse shell. Okay, so that's the whole idea. Yes.
What will happen if you put -e/bin/sh in the attacker side? On both sides. What will happen?
That I don't know. That I kind of don't know. Maybe try it out.
Will it be a double side?
Maybe I can try in here, but I don't know what. I didn't try that, but I can try. No, it doesn't work. It doesn't work. So that's what you can do with Netcat. Okay. Yeah.
What will happen in host 2 is just like the launch of a Netcat using the first command. So we just type pwd in the host 2 and what will happen? Anywhere in the directory of host 2 or in host 1. Using the first command you type in.
You can try. Well, I can also try in here, but there's nothing. But the key idea is that you are an attacker. You want to remotely control a victim machine. So that there's no reason to execute something on the victim's side. Right?
I mean that the connection after the connection is established, then the host 1 is in the directory of host 2, but what will be the
there will be no response. Okay. For example, in here you make a connection. Okay. Now on host 1 you type pwd, you push something from left to right, but in here there's nothing you can do. So that should show response. It's always the yeah. So I think it's. Any questions? So there will be a lot of tools that you can play around. Actually, you can just download these tools. Netcat is a very well-known tool. I think right now there's a newer version called the NC. It's just called the NC, and the options are a little bit different. Okay, but you just make sure you download the correct netcat. Okay, when you install Ubuntu, you may find an NC, but this NC program may be different from the NC in here. Okay, make sure that you are running the right netcat. Just make sure you go to the netcat homepage and download the correct source code. Okay, so in that case, we will start another lecture 5. Okay. Now, again, we still talk about the network attack. Okay. In lecture 4, we focus on a smaller scale network attack in the sense that two people are talking to each other, and you want to gain the access to these connections. Okay. Somehow the damage by itself is very small scale. Okay. You only affect maybe just two parties. Okay. Now, large scale network attacks is to make the attacks in a bigger scale. You're not only trying to compromise one single machine. You may want to compromise the whole network. Okay. And this is something we are going to talk about in here. Now, of course, when we talk about this concept, it's very difficult to show you some demo because you really need to have a network in order to show this kind of attack. But so this lecture is kind of more theoretical in the sense that maybe there's not much demos that I can show you in here. But I would just like to point out that actually these type of attacks really exist. And actually, people have been doing a lot of research in this area. So what I want to talk about in here is this kind of research activities related to how we do the large-scale network attacks. Okay, so it's more like an introduction. So hopefully, you will still find it interesting. Okay. Now, last time we talked about the network attacks. Mainly is to exploit the weaknesses of the fundamental features of network protocols. Okay, so it's very difficult to fix because these weaknesses appear in the fundamental protocols, fundamental features. Unless you change the fundamentals, otherwise the weaknesses will still be there. Okay. Now, the attacks that we talk about in here is even worse in the sense that it's not the protocol itself, but it's the fundamental limitations of the hardware. The idea is that it's really the computer by itself has only limited resource. Unless you scale up the resource, otherwise there's no way for you. Whenever you change the protocol, the amount of resource that you have is the same. So one type of large-scale attack will be something called a DDoS attack, is to launch the denial of service attack from many compromised hosts. It doesn't really matter about the protocol by itself. No matter what kinds of protocol that you have, this attack will still work. Now, one student just asked me, okay, in TCP exploit, you can shut down a connections, but if you're using VPN gateway, there's no way you can do that with TCP exploit. But is there any other way you can shut down the VPN connections? And maybe that's one way that you can do is to launch a DDoS attack. Just shut down the whole VPN gateway to consume all its resources. Okay. Now, how do I do that? Probably I would talk through step by step. Okay. The first thing is now the whole idea about the DDoS attacks is to launch the attack from many hosts. Now the thing is, what you want to do is you want to compromise one host and one other host. Okay, one host by one host, and then once you compromise enough number of hosts, then you can launch this attack. So the question is how to compromise one single host. And what we do in here is we start with the port scanning. The idea is to find the vulnerability of one single host. Because for some of the service, we know that there's some vulnerability. If I know that this service is open, then I can launch the attack to this service. So the question is, how do I know that this service is available for me to attack? Worms is a larger scale of port scanning, meaning that I can do the scanning in a much larger scale. Okay. And DDoS attack is that once I compromise enough number of hosts, then I can launch the denial of service attack. And finally is the botnet. I can use this compromised host to launch many different types of attacks. Not only the denial of service attack, but I can do other things. For example, I can send some fake request. For example, let's say the voting. Okay, I can use the botnet to control a lot of machines to do some fake voting, to vote for someone that should not be. Okay, so this is the type of botnet. I'll talk about these concepts one by one. Again, it's a little bit theoretical, but I will just talk about the concepts in here. So what I wanted to tell you is to understand these existing attack strategies, to try to identify some novel attacks and try to help us defend these type of attacks. Now, these large-scale attacks are still some ongoing research issues. We don't know if there are any new attacks that would be feasible. Okay, one type of research is to find new attacks. Okay, and also based on existing attacks, some of them may not have good solutions to defend. So there's a lot of research on how to defend against these existing attacks and also any potentially new attack. Okay, so we will talk about that in here. Okay. So let's talk about the port scanning. So this is the first step. You want to compromise a host. Now, the idea of port scanning is to identify if a port is open. Now, a port is open means that a process is listening on this port. For example, if you're running a web server, it should open at port 80 so that you can connect to port 80 to get the HTTP request or response. Now, in that case, I know that there's an HTTP server is running. Okay, so other ports may imply that the corresponding services are running. Now, the range of ports will be from 0 to 65535. Okay, it's a 16-bit value. Okay, so it could be any value from 0 to 65535. Now, however, the community defines some well-known port numbers. Okay, so these port numbers are not supposed to be used for other applications. They are reserved for some well-known applications. For example, HTTP should be expected for port 80 should be expected for HTTP only. So what that means is, when you go to the browser, you usually just type in the URL, but you never type in the port. The reason is that because the browser assumes that the default port will be the 80. Okay, this is reserved for the HTTP, so that you can safely assume that this will be the default. Now, FTP will be 20 and 21 for the data and control, and DNS will be 53. Okay, and you can also find out the list of port numbers that are defined to be the well-known port numbers. Okay. Now, the port number is just like a door. Okay, it's just like you go to the building and you find out the room number. Okay, so so the building, the address of the building will be the IP address, okay, and the port number will corresponding to the room number. You can think it this way, okay. Now, the idea of port scanning basically is to identify if a port is open or not. Now, there are two types of scanning in here. One is called the horizontal port scan, and one is called the vertical port scan. Again, the whole idea is to identify the range of ports to see if they are open. Now, horizontal port scan means that you want to scan a range of hosts on a particular port. For example, I want to find out in the CSC network whether the port 80 is open in any one of these hosts. So in this case, that will be the horizontal port scan, because I want to scan all the hosts within the CUHK network on a particular port 80. Now, vertical port scan basically is to focus on one single host to fix the host, but you scan all the ports. Okay, so there will be up to 65535 number of ports. Okay, so this is called a vertical port scan. So you scan from 0, 1, 2, 3 up to a certain range on a particular host. So that will be the vertical port scan. Now, of course, when you do the scanning, you can do both horizontal and vertical port scans. Okay, and the attacker, what he wants to do is to find the open ports and then try to find the vulnerabilities on these running on these ports. Okay. Now again, there are many open tools, open source tools available for people to do this scanning. Now, Netcan is one tool that works. Okay. Now another tool is called the mmap. Basically, it's a very powerful port scanning tool, and more importantly, it provides a lot of scan types that make the port scanning more stealthier. Okay. Stealthy means that this port scanning is very difficult to be identified. A stealthier attack means that it is more difficult to identify the attack. Okay. Now, in fact, you can actually send very few packets, but you can tell if the port is open or not. Okay. So I will talk about different scan types that are actually available for inside mmap. Now, some scan types may be very maybe less stealthy in the sense that the system may be flooded. Okay, so in this case, it will be very easy for the administrators to find out who is doing this bad thing. Okay, so when you do the port scanning, make sure you do it in a stealthy way. Of course, that's from the attacker's perspective. Okay. Now this is what we call the mmap. Again, mmap is a very well-known tool. You can just do a search and you can download this. I think it's also available in a lot of Linux systems. Okay. Maybe I will show you one example here. Maybe I will just do a scan on one machine. Now, mmap is installed on my machines. Okay, let me show you one example. Okay, let's say I want to do a scan on, let's say, the SPARC1 machine. Okay, now this is the TCP sync scan, which I will talk about what that is. Okay, now you may, I think you may need to run in. It will take a while. Now the idea is you do a sync scan. This is actually the vertical port scan. Okay, you do a sync scan on a range. By default, it's all the ports. Okay, on SPARC1. Okay, SPARC1 is one of our department's machines. Okay, it will take a little bit while because you need to do all the scanning. Okay, so these are the outcomes. So you can see that right now on SPARC1, now 21, 22, 23 are open. 79 is open, 79 is the finger. Okay. All the other ports are open. Some ports we don't know they are open. Okay. So you can see that these are the open ports. If I were an attacker, what I would do next would be, okay, I know this port is open. I will try to find the vulnerability to see if I can hack into these ports. Okay, so this is the way of how you can do mmap. Now, of course, try not to do it in the department because you're not supposed to do that. Okay, so let's talk about different scan types. Okay, to see how you can make your scans stealthy. Okay, sync scan, the thing that I just showed you is not the stealthiest scan. Okay. Now, this is the most basic scans will be the TCP connect scan. Now, what is TCP connect? When you call the TCP connect in socket programming, basically it will launch a three-way handshake. Okay, you send a SYN. Okay, you expect to receive a SYN ACK, and you provide an ACK. Okay. Now, this one is not good. Okay, in the sense that why? Because think about this: how many packets that you send for each port? Okay, that would be 3. Okay, you send one packet, you receive another packet, and you send an ACK. Okay, so for each port that you scan, that you will use 3 packets. Now, if you are scanning 60,000 ports, then you will have 180 packets, which is very difficult for the attackers to find out. For the administrator to find out. If you're doing this in the department, you probably maybe get caught very easily. Okay, so just don't do that. Okay. Now, of course, I'm not saying you cannot use connect, but the thing is, if you're doing connect within a very short time, but doing this many times, then most likely you are doing an attack. Okay. Now, this is the behavior that I would expect from the port scan, meaning that you send out a lot of these scan packets within a very short time. Now, this is the way of how people do the attack. If you minimize the rate, basically we won't consider it to be an attack. But if you do it in a very high rate, then you may be considered doing an attack. Okay, so this one is not good in the sense that for each scan, you have 3 packets involved. Okay. Now this one is called a TCP sync. Okay. Now TCP sync is the one that I showed you in a moment earlier. Okay. So the idea is you send a sync and you wait for the sync ACK. Okay. Sorry. In TCP connect, if the port is open, then you will create connections. Then you know that the port is open. Otherwise, it's not. Okay. So you can tell whether the port is open. Now, sync scan is also very similar, but this time, because your purpose is just to create an ACK, okay? So you just want to check if the port is open. You don't need to really open a connection. You don't really need a connection. So after you get the sync ACK, you know that the port is open. So there's no point for you to send back an ACK. Just let it half open, okay? So if the port is closed, then the destination will send a reset or nothing. It depends on the operating system where it will respond, but usually for TCP sync scan, you will do it this way. So the key idea is that you don't complete the three-way handshake. You just send a sync, you wait for the sync scan, sync ACK, and then you don't do anything. Now this is stealthier in the sense that right now, instead of using 3 packets, you use 2 packets for each port. Okay, so this is stealthier, and you just use the option SS to specify this is a TCP sync scan. Okay. Now another scan is called a fin scan. This time I don't send a sync, but I send a fin to a port. Okay, now. Fin basically in here is if the port is open, that should be nothing, okay? Because remember, if you send a fin, the sequence number doesn't match, okay? So in this case, the other side will just drop the packet, so you know that the port is open. However, if the port is closed, if you send a fin, most likely the operating system will just send back the reset. Okay, so usually if there's no response, the port is open because you will just treat it as a wrong fin packet. But if the port is closed, the operating system may decide to just send back the reset. Okay. if that's the case, then you can tell based on the reset, you know whether it's open or not. But of course, if the system sends a reset anyway, if the fin you send to the TCP is not expected, it will send back to you the reset, then you are screwed. Okay, so this doesn't work. But however, in most operating systems, usually if the TCP port is open, when you send back the fin, because the sequence number doesn't match, so you don't expect anything. So in this case, you may infer that the port is open. Otherwise, it will be closed. It will send you a reset, and you expect that this will close. Okay. This is stealthier than TCP sync. Why is that? Okay. You think that that's also true packets, right? So in TCP sync, you send a sync, and you get the sync ACK. Here you send a fin. If the port is closed, you send a reset. Okay. So this would be this should be less stealthy, right? But this should be more or less the same. But actually this is even stealthier. Now you may think in this way. Okay. Now we only in here to identify the open ports. Okay. So if you just look at the open ports, right now you only use one packet to identify an open port. But for this one, you use two open ports. Now, if you just look at the open ports, now usually, for example, if you're doing if you're scanning port 80, it's likely that port 80 will be open. So in this case, the fin packets will be in this case, the fin package will be you just use one packet to define it as a host. And I think another reason is that this fin packet is I should not say in this way. Maybe I just keep the same. So basically, you just use one fin packet to identify an open port. That will be stealthier than the sync packet, which use two packets to determine if a port is open. So that in that sense, this is stealthier. Okay. Now another one is called the OS fingerprinting. That one is a little bit tricky. You look at the how you respond to some illegal combinations of control bits. I also don't know how it works, but this is the idea is you look at different operating system and how it responds to different control bits. And so I don't quite know this behavior, but this is the option that is provided. Okay, so so these are the scan types that are available for you to define. So determine if a port is open. Now Nmap again is not a back tool. Supposed to be used for good purposes, but the thing is, and the administrator really needs this tool to find out what is the services being running on the machine. Now, sometimes if you look at these ports that I show you in here, you may find that hey, some ports are really not necessary. For example, telnet, nobody is supposed to use that anymore. So I may find that I may check my own machine to say, hey, this port is running 23, I may just close it, okay? Or maybe if you find some port is unexpected, maybe you're running some backdoor, okay? This is really for good purpose. But it's also being exploited by the attackers to find out whether the port is open or not. Okay, so this is the port scanning. Any questions? Now, to defend against the port scanning, maybe you just don't want people to scan your ports, okay? One thing you can do is close all the unused ports, okay? Just let them scan you, but just don't open the ports that you don't need, okay? That's one way. Another way is just block all this scanning. Okay, you use the IP tables. Okay, you restrict the range of the ports to be accessible. Okay, maybe you just want to allow, let's say, port 22 to be connected from one single machine or from a subset of machines, not all the machines in the department. So in this case, you may just block the ports so that even though you scan, I cannot tell if your port is open or not. And you can do that with IP tables, okay, which I will talk about that when we talk about the firewalls. Okay. And another thing is you can use the network intrusion detection system to find out if there's any scanning happening. Now again, one pattern of the scanning is that you do a lot of these scans within a short time. So you can use this pattern to infer that an attack is happening. Okay, I will talk about that in the next lecture. And also this is something that you're going to do in your assignment. But scanning basically is the first step to compromise a host. Okay. Now another attack is, okay, the second step is we talk about the denial of service attack. Well, when we talk about large-scale denial of service attack, we really want to have DDoS attack, distributed denial of service. But to go to this one, we have to talk about the non-distributed version, which is the DOS attack. Okay. Now, we talk about denial of service attack a little bit when we talk about TCP exploit. This is one way of denial of service attack. You don't really need to gain access to a connection. You don't really need to access the information inside. All you need to do is just to make sure that the other person cannot use the service. That's what we mean by denial of service. Okay. Why people cannot use the service? For example, they don't have enough computing resources, or it's because the connection is closed. Just the service is not available. Okay, so denial of service attack requires less assumption. For example, when you want to gain access, when you talk about using the sniffer, you probably need to assume that this is a broadcast medium, so that you can listen to the traffic. Okay, but denial of service attack doesn't really assume this type of assumption, and also it doesn't have to be in the same network. It could be some network on the other side. It could be the White House web server. Okay, you can still launch the denial of service attack. Okay, so it doesn't have to be the same network. So the assumption required for this attack to work is very small. Okay, you don't need many assumptions. Okay. The whole idea here is you want to deny the access of legitimate users and stop some critical system process, so that the legitimate users cannot use the service. Okay. Now, how to do that? The whole idea is to consume the resource available for the service. If the service doesn't have the resource, then it won't work. Okay. Now, DOS attack actually happens every day. Okay. I think people are doing that recently. They want to use the Java. That's not really related, but actually people are doing that every day, and you can actually see the denial of service attack in some well-known websites. Okay. Now people are not just doing it for fun. Now people, when people talk about security, you ask why the attackers want to do the bad thing. Usually the legitimate reason is, okay, people want to show that they are smart, they know how to use the computers. Okay, so they launch the attack. But actually there's a business incentive. Actually, you may want your competitor to screw up. Okay, for example, you may run on some e-commerce websites. Okay, you don't want your competitor to run any business. Then you may want to launch the denial of service attack to these websites and bring it down. Okay, and actually there are cases to show that actually these attacks have the business reasons to do that. So the attackers are not just doing it for fun, they're really doing it for money. And denial of service attack is the simple attack that they can launch. Okay. Now, there are many ways you can do that. You can do it locally, okay, which means that you go to the machine, you kill the process, okay. So this is what you can do, but this is not interesting because everyone knows how to do that. Okay. Now remotely means that you generate the attacks from outside, and there's no way for the victims to control. Okay, so the attackers will generate the attack traffic to the target machine across the network. That makes things more complicated. And in here, we will focus on the remote DOS attack. Okay, how to launch the attack remotely. But the whole idea is the same. You don't want the service to be available. Okay, you deny the service. You want to make it unavailable to the legitimate users. Okay, so we will focus on the remote one. Another way is how to make the service unavailable. Either you just kill it or you consume the resources. Now, this is the most common way we launch the denial of service attack. The idea is you try to prevent the users from getting enough resources to reach the service. For example, you flood the machine with a large number of packets, so that the packets need a lot of so the machines needs a lot of resources to process these packets, so that they don't have remaining resources to process other legitimate packets. So this is what we call the resource exhaustion. And in here, we will focus on the remote attack based on the resource exhaustion. Okay. Now this is the classic approach of doing flooding. Okay. Now, of course, one simple way you can do is, okay, I just generate a lot of packets, let's say UDP packets, then it will work. Okay. But usually, you may need to generate a large volume of packets, which make things, you very easily detected. Okay. You don't want to be detected. So somehow you may want to do the flooding, but in a less scale. You generate less attack traffic, but you can still succeed in the attack. Okay. So this is what we call the sync flooding. You don't need so many packets, so much attack traffic, but you're still able to make the attack successful. Okay. By the way, when you do the flooding attack, you may generate TCP packets or you may generate UDP packets. Which one you should use, UDP or TCP? TCP or UDP? It should be UDP. The reason is that TCP has the congestion control. Okay. The idea is, if you generate a lot of TCP packets, the receiver side doesn't have enough resource to process these TCP packets, so the sender will back off. Okay, will slow down to make sure that the receiver side has enough resources to process the packets. Okay, it's the congestion control mechanism that will limit the rate of the packets, which is clearly what you don't want from an attacker's perspective. UDP doesn't have this problem. UDP just you just do your best to send out as many as you can. Okay, you may experience packet drop, but in the attack case, it's not really a problem. Okay, so if you are an attacker, if you want to do the flooding attack, you use the UDP packets. Okay, just to consume all the resources. Okay. Now, sync flooding is a little bit different in the sense that I still do the flooding, but I want to consume other types of resources, which is the memory resources, to remember the state for the sync. Okay. Now, how does it work? Now, the idea of TCP is like this. You do a three-way handshake, right? So, you send a sync, okay? The receiver side receive a sync, okay? Accept these connections, and it will send back a sync act, right? Now, in the meantime, the receiver side will also create some state to prepare for this connection. Now, this state information will take some memory. okay, is quite a lot of memory if you have many connections, okay. It just, you need this memory to remember a lot of TCP, some many protocol information, which also I don't know, but you need some memory to keep the states. The thing is, if you generate a lot of sync, you will create a lot of connections. So eventually the server will have insufficient memory to keep all these state information. Now usually memory resource is very limited. Now compared to other types of resources, memory is relatively more limited. So if you're able to do that, you don't need too many packets, but you're still able to consume the memory of the other side, to use up the memory to remember the states. Okay, so this is the whole idea of sync flood. Now the thing is that when you send a sync and you will reply sync ACK, the attacker side just stop. Okay, the attacker just stop. So in this case, that will be the half-open connections, and the memory will be there for some time. Okay, now this stage won't be taken out because it will expect an ACK, but the attacker doesn't send back an ACK, so this memory will still be there. Now if you're doing this for a lot of connections, basically the memory will use up. Okay, so the whole idea is you make the connection half open so that the memory remains idle but cannot be released. Okay, so in this case you will consume more resources. If you send a lot of sync flood, then you will make the you will consume all the memory resources. Okay. Now to make things worse, usually the sync packet will use the spoof IP address. Okay, you don't use your own source IP address to tell you, hey, who is the attacker, right? You don't want to do that. Okay, and also it doesn't really matter because once I send a sync, I won't send another ACK. My purpose is not to set up a connections. Okay, so even though the sync ACK is sent to nowhere, it doesn't really matter. Okay, so that will force the server to keep the state for a long while because there's no response about the sync ACK. And by choosing a large pool of spoof addresses, the detection will be much more difficult. Okay, so this is the whole idea of sync flood. And by flooding, you consume the resources in two ways. One is you fill up the connection queue, the queue that is used to remember the states. Okay, and also if the link is limited, you also fill up the communication link. Now, of course, this one may not be doable right now because actually, right now, if you're talking about 1 gigabit links, this should not be a problem. Okay, but back in the old days, this one has limited bandwidth. If you send enough number of sync, then that's also a problem. But really, when we talk about the resource exhaustion, we look at this first one to fill up the connection queue. Okay, the idea is you leave the state half open to make the state to be in the server for a long time so that you can consume its resources. Okay, so this is the whole idea. Now, this is actually very simple. People know that for a long time. So how do we defend it? Just buy more memory. Okay, this is one solution. Okay, but if this is the case, then there's no way. Then the attackers can just buy more memory, right? To send more sync. Okay, so that's not really the feasible solution. A proper way to do that is just don't create a memory to remember the state. Okay, the idea is that you right now trade another resources, which is the CPU resources. Now memory is limited in the sense that once you use up the memory, you can't do anything. For CPU, you just slow down, but you don't stop. Okay, so you need more CPU resources to do the computation but compared to memory, usually this one has more resources. So you want to trade the CPU for the memory. Now, so the whole idea here is that I don't keep track of the state, but I use some algorithm to check if I should open the state, should the connection be open. Okay, which I will talk about that. Okay, this is called the CUHK. Okay, so and it's already implemented in a lot of operating systems. Okay, so let's see how it works. Now this is the three-way handshake I showed you earlier. So A sent to B will be the same, the identity of A as well as the sequence number of A. Okay, B will send back to A will be the sequence number of B, and and also enlarge the sequence number of A plus 1. Okay, and A sent to B the ACK. Now, in B, when B sent to A, the memory will be half open. Okay, but this time this sequence number is not generated randomly. Now, in the default TCP setting, the default TCP design either is always set to 1, okay, or is some fixed number designed by the operating system, or just some random number, okay. But this time is somehow generated based on some well-defined algorithm, some intelligent algorithm, and the idea is based on a cryptographic function. So the idea is that it is generated based on the source IP address, port numbers, time, and the secret seed. And this sequence number is what we call the single key. Okay. And once Bob replies the sing ACK, immediately the open state will be forgotten, and no connection queue will be used. Now, the memory will be released. Now, the whole idea is that you generate this sequence number B, okay, based on some cryptographic function. And once you generate this number, it will just release the memory for this connection. Now, why this will work? Remember, for sync flood attack, the whole idea is the attacker doesn't want to create a connection. Either it replies an ACK, so in this case it makes the connection open, but to reply an ACK, you make sure that the IP address, the source IP address is correct, but that will reveal the identity. So usually sync flooding will use some spoof IP address. But when you use spoof IP address, when you reply in sync ACK, it should go nowhere, and it should not receive any ACK. Okay, so in this case, there's no problem. No memory will be left for idle for a long time. So in this case, I will be able to defend against the sync flood attack. Because when you send a sync ACK to nowhere, there's no ACK anyway, so no memory will be wasted. Now the problem is, what happened to the normal connections? What happened if there's an ACK really coming? What happened if this is really belongs to a legitimate connections? So how do I create a memory back? Okay, so this is the idea. So the idea is like this. In the normal connections, if there's really an ACK, if this is really a real three-way handshake, so you will reply the ISMB plus 1. So the bot needs to verify that, hey, this ACK is really for these particular connections. So you will need to check if this ISMB is legitimate. Now, how to generate this ISMB? So it's based on the 4-tuple, the source destination IP and ports, some time, okay, and some secret seed, okay, maybe the time here is the date, okay. So make sure that the connection is valid only within a date or within the current minute, let's say, okay. But make sure that the input is always the same, okay. So you keep the input to be the same, okay. So you can regenerate the same ISMB, okay. Keep all the inputs to be the same. You will generate all the sequence number B, okay. Now, once you validate that this B actually maps the corresponding ACK ISMB plus 1, then you know that actually this ACK is legitimate, so you can proceed. You create a memory for that. Now, if I were an attacker, I don't expect to see this ISMB. Okay, so I have no way to predict what should be the ISMB, because the attacker needs to find out the ISMB correctly. Okay, the only way you can find out easily is look at the sync ACK, but it will reveal the source IP address to the bot. Okay, so it's not feasible, and also it's very difficult for the attacker to guess what is the ISMB, because it's based on the cryptographic hash. So in that sense, it will be very difficult to force the bot to create a memory for this state. Now, if truly send some spoof sync packets, bot doesn't store any state, so that's no problem. Okay. Now, of course, one thing to do the attack again is, instead of consuming the memory resource, maybe I consume the CPU resource by generating a lot of this ACK information. Okay. So again, that's not quite easy, because compared to memory, the CPU resources is much more. So in that case, this one would work. Okay. So the idea is you trade the CPU resources for the memory resources. Okay. Actually, this is already available in Linux. So one thing you can do is just put a 1 to enable this option in the processes, then it will work. Okay, it's just this process file, then it will work. Okay. Another way is just to limit the sync flooding. So the idea is you try to upper bound the number of incoming sync packets, but of course that's not quite good, because you may really want to support a large number of sync given your available resource. If you put a limit, then you may limit the amount of service. But that's one way you can avoid being sync flooded. Okay. Any questions? Now, if not, I will stop in here. Next time I will continue on the large-scale network attack. Now, assignment 2 will be posted probably this Sunday, so please make sure you check out. I think the TA already started discussing assignment 2, so please make sure you do it early. Okay. If you have any question, you can ask. Thank you.
拿 sequence number 来记那个代替的。知道不干嘛？拜拜。拜拜。
演呗。就给我打个招呼看，然后我就打，拜拜。
中中去哪儿？
大伟啊。先走吧。
好，拜拜。
拜拜。